There we go. Now everybody should be able to hear me just fine. So we'll start that over again. Good afternoon, and thank you for being with us this afternoon on this AWS Restart presentation on how to build scalable web applications. My name is Michelle Metzger. I am a senior technical curriculum architect with the AWS Federal Training Team, and I've been with AWS for about 3 years now. Super excited to be with you guys this afternoon as we cover this topic. So the agenda here, fairly straightforward. We're going to talk about how to architect a web application starting from one user all the way up to millions of users. We'll go through the architectural elements, what services and features are used to help us gain the additional traffic utilization, database usage, all of those things, all the way up to that high, ginormous scale websites that are so commonly hosted using AWS services. All right, let's start with that very, very small audience, an audience of one. So when we jump into this, the first question is, which AWS service is it that allows us to host a server on AWS Cloud? Yeah, it's Amazon EC2, our Elastic Compute service. This service will allow us to create a virtual server in the cloud for which we can install our web application itself, as well as the database that will be supporting that web application. Now, we have other options as well within AWS to do this. We could use AWS Lightsail, or excuse me, Amazon Lightsail, which allows us to set up a web application with a very friendly user interface. When I first started at AWS, this was my very first software solution I got to play with. I built a website, it took me, I don't know, 20 minutes, I think. It was awesome. It's a very, very neat product. We could also set up something with AWS CloudFormation, which allows us to actually configure an entire architecture, and even software solutions like AWS Beanstalk, where I can load my application into Beanstalk and it takes care of the deployment, the building, all of those pieces and parts for me directly. Okay, so we're going to use Amazon EC2. The next question is, what do I need to have in order to be able to connect to EC2? Yeah, I need to have the management console set up, the AWS CLI, or SSH. And that's what's going to allow me to be able to communicate to my EC2 instance. Now, all three of these mechanisms require that I have an IP address configured for my EC2 instance. Now, this IP address could be a static IP address for that instance, but more likely, and what's going to be a better fit for our scenario, is to use an elastic IP address. There are a ton of different benefits when it comes to an elastic IP address. The foremost benefit is that this address can be utilized in scaling scenarios, and in the case of a disaster scenario, this IP address can automatically be assigned to a different EC2 instance without the front end needing to be aware of that. Now, let's talk about what is that front end? How does my user actually get to that IP address? So from a network point of view, where does the EC2 instance live? Yeah, it's going to live inside of a VPC, a virtual private cloud. That's what's going to contain the EC2 instance that we are going to be using for our web application. Now, there's another step, which is, how does my computer out here on the internet know how to get to that EC2 instance? How does it know where that web application lives? Yep, I have to be able to route to it using DNS. AWS's DNS service is called Route 53. So I would configure Route 53 with the elastic IP address for my web instance, and that's what's going to provide me with the connectivity from my user into my web application. And so voila, here we have it, a very basic web application architecture that's going to service, tens, even maybe hundreds of users to be able to access the content that I have on that EC2 instance. Now, even our largest EC2 instances are eventually going to get outpaced by traffic that may come in to our website. And so we have to be able to move then from just servicing a small audience to servicing a larger audience. We get into now the architectures for our medium-sized audiences. Now, what we have at this point is we have our users connecting via Route 53 to our Elastic IP address, which is in connection to our EC2 instance. So when we jump up to a medium-sized audience now, what we need to do is we need to start the process of decoupling. Now, when we talk about decoupling, the first step in this is to actually separate the web application itself from the database that is servicing it. Now, this is really important because when we work with the web application, there's commonly two activities that are performed. One is I'm just servicing the user interface that the user is connecting to. And two, I'm pulling data dynamically from that database. By separating these two workloads or decoupling them, it allows me to service more requests because now the EC2 instance is not handling everything because all database traffic is now going to the database instance that I'm working with. This decoupling is the very first scaling that should be done for any web application. Now, Amazon has a lot of different services that provide this database capacity. These services come in two broad categories, self-managed and managed databases. So does anybody want to take a stab at what a self-managed database would be here within AWS? Yeah, Amazon EC2, again, we pop up our server. It allows us to install any database engine we would choose. We could install SQL Server, we could install DB2, or we can go open source and install MySQL, PostgreSQL, any of those databases on the EC2 instance. Now, the advantages of a fully self-managed database is that I have the ability not only to work within the database instance itself or the database engine, but I can now communicate to the operating system as well. This allows a lot of highly complex types of operations to be performed within the database itself. It's very common that we see this with Oracle databases and with Microsoft SQL databases as well. Now, if I'm looking for an option where I'm able to now share some of that management workload with AWS, we have our managed and fully managed database services as well. Now, we have a very wide range of these database services. We're going to talk about two types of database services today, our relational database services and our non-relational database services. Now, for relational database services, our base service is Amazon RDS. This database service handles the requirements of our relational database needs. We're able to install 6 different database engines. These include things like our open source databases, MySQL, PostgreSQL, MariaDB, and it also includes some proprietary database engines such as Microsoft SQL. We also have a serverless database engine type called Amazon Aurora. This gives us the flexibility of running in a serverless environment while being able to share that management workload back with AWS as a fully managed service. In fact, we even offer a service called the Database Migration Service, or AWS DMS, which will help us take whatever database we had installed in our small little database instance and migrate it cleanly and carefully into Amazon RDS or Amazon Aurora. Now, if I'm working with non-relational or what's commonly called NoSQL database engines, we have Amazon DynamoDB to meet that need. DynamoDB is a database that provides that non-relational database platform while giving us unprecedented reliability, resiliency, and scalability, all 100% managed by AWS. Now, one of the technologies that is becoming more and more popular is a graph database. These graph databases are used to provide things like product recommendations on websites, a lot of content behind our social media websites like Facebook and Twitter use graph databases to provide those relationships or connections between users and data. In the world of AWS, we have Amazon Neptune to meet that requirement. It is our premier graph database service. So at this point in our journey of building our scalable web application, we have to decide which database service is the right service for the requirements of our web application. Now, the answer is they might all meet certain parts of our database requirements, especially when we get to that gigantic size, which we'll get there a little bit later on this afternoon. For right now, we're going to hit that most common average use, which is going to be Amazon RDS. So we have our EC2 instance, which is going to be housing our compute resources. And then we've got Amazon RDS, which is going to be handling our database requirements. So the next step is we really need to dive in and think about our users. How are our users going to be communicating with our website? What requirements do I have? Do I want to let anybody come and hit my website and use it just as a public medium? Or do I want to implement a registration process so that I know who my users are? Do I want to require them to sign in? Do I want to have parts of my website that are private only to registered users and other parts that are public to anybody that comes across the web? These are all what we call user stories. And hopefully we've already clearly defined our user stories before we implemented our website for our small little audience. As our audience grows, however, those user stories may change, they may migrate, they may grow. And as they grow, at each point in time that we are planning for that growth, we need to reevaluate these user stories and we need to ensure that we understand what needs to change to meet those requirements. So let's start with the most obvious need, which is authentication. How will my users authenticate to the website? Now, there's lots and lots of different options out there. I could use open source and use OAuth to be able to authenticate. I could use a homegrown built out solution that uses that OAuth standard. I could require federation. I can require a user directory. There's lots of different options, most of which are pretty manual in their applications. Now, AWS offers a fully managed service called Amazon Cognito. This is going to allow our application developers to focus on what's special about the application itself and developing an amazing application without having to spend a lot of development hours on the authentication piece itself. Amazon Cognito also allows us to be able to very quickly and easily provide federated authentications to our users. I mean, this is one of the most popular things about the web right now is that I can authenticate to websites using my Facebook credentials or my Amazon.com credentials. That's what we want to be able to provide to our users: convenience, flexibility, and Amazon Cognito is a perfect solution for this. Now, as we grow and as we change, we may want to have a little bit more control, not only over authentication, but over the security of our application from end to end, from beginning when we have just a couple of users to the end when we have 1 million users. This requires a little bit more power behind us, and we move into the security of the environment itself. AWS Identity Access Management, or IAM, is the primary service that provides user management within the AWS environment. And so what this does is it provides us the ability through the use of IAM policies to control or restrict and allow access to resources within our AWS account. Now, this could be authenticating a website interface to a database. This could be a specific user authentication as well. Now, once we take care of the users, the next step is to begin the process of protecting our environment. Now, AWS CloudTrail is one of our primary services for monitoring the authentication activity that is happening within our environment. AWS CloudTrail monitors the logs within other configured services and gives us the ability to audit those logs by tracking API calls. Authentication is a series of API calls, but it can track all API calls. Now, there's another service out there that is commonly confused with CloudTrail, and that is AWS CloudWatch. These two services have very different requirements or very different results. CloudTrail, like we just discussed, keeps track of our logs and allows us to log API calls. CloudWatch does not look at the API calls. Instead, CloudWatch looks at system metrics within our various services and reports and even notifies and alerts on those different system metrics. So it's really important not to confuse these two services because they have very different uses. All right, we have a couple of other services listed here that help us to protect our environment: Amazon Guard Duty and AWS Shields. Now, AWS Shield is wonderful because it's actually free for all AWS user accounts in its basic configuration. What it does is it identifies when our system is experiencing unprecedented traffic. One of the most common types of attacks out there on the internet right now are called distributed denial of service attacks. This is what AWS Shield is excellent at identifying. It identifies that unprecedented traffic and it actually stops it in its tracks. Now, we also have AWS Shield Advanced that goes a step beyond just detecting it and stopping the traffic, but it also moves into mitigating the attack and even helping your company to recover any undue expenses due to any attacks that you may have sustained. All right, this is protection. Now, beyond protection, there are a lot of other security concerns that go into an architecture and application that we may be working with as well. Things like AWS Web Application Firewall or WAF, AWS Secrets Manager, AWS Certificates Manager, and AWS Key Management Service all help us to protect items within our architecture. Now, hopefully you guys are all aware of what a firewall is and what a firewall does. With AWS WAF, it allows us to control access into and out of our environment using access control lists and identifying other features at the application layer within our network. Our certificate manager and secrets manager allow us to provide a managed service that obfuscates the actual credentials from our application code, allowing us flexibility to do secrets rotations and things of that nature without having to go in and refactor our applications, right? I think all of us have learned at the very beginning, never hard code our credentials, never hard code certificates. These services help us to meet that requirement by allowing us to instead code the access to the token or the replacement system instead. AWS Key Management Service, or KMS, is our encryption technology. This supports both server-based and client-based authentication, or I should say encryption standards. It allows us to be able to encrypt all of the traffic and data, both in transit and at rest within our AWS environments. All right, now that we've learned a little bit about security, let's go back to our architecture. So at this point in time, what we have is we have our users that are connecting into Route 53. From Route 53, they're being sent to our EC2 instance that's hosting our web application. And we have a generic database over here on the side that's actually holding all of the data that's going to be used by that web application. The goal here, of course, is about the decoupling of those two pieces and parts. And that gets us to our minimum level, handling a medium-sized audience that we're working with. All right, let's bump it up a step. Let's talk about a large scale audience now and the changes that would be incurred for that larger scale audience. All right, our goal when we move to a large audience is to provide to provide both resiliency and scalability in our solutions. All right, so our users are communicating down to Amazon Route 53. Within a single VPC, we have the ability to provide resiliency. Does anybody know how we do that architecturally? Yeah, we use availability zones. And so by having our web application now split across multiple availability zones, we are able to survive in the very rare event that we lose a resource inside of one of these availability zones because we have assets in both. Now, in order to be able to funnel that incoming traffic to multiple availability zones, we have to set up a service that does that for us. Does anybody know what the service is? Yeah, it's Amazon Elastic Load Balancing, or ELB. Now, with an Elastic Load Balancer, we're now able to register our EC2 web instances that are in two different availability zones. This allows me to handle double the traffic, right? The beauty of, for instance, our application load balancer is that it can pay attention to things such as the health of these EC2 instances. And if it notices that one of these EC2 instances is just not quite performing well, maybe it's overloaded with activity, it can dynamically begin to switch more of the traffic to the web instance that is healthier and begin that process of identifying other instances that the traffic can be sent to. That's our load balancer. Now, it is fairly straightforward and simple to take a web application, to duplicate it on another system and have an identical copy. I could have 4, 8, 12, how many ever copies of this application that I want to, and they can all run in parallel. Databases, that's a little more tricky. With databases, they don't duplicate the same way. Well, I could just photocopy it, right? Yeah, I could. But what happens when somebody uploads new content to the database? How do I make sure that both copies of the database have that record? Yeah, that's why it's a little more tricky. So let's talk about how this works. Now, with Amazon RDS, we create what is called an active instance. This is the primary Amazon RDS database. Now, all database requests from both of our web instances in the two AZs are going to go to that single active RDS instance. Now, for the purpose of resiliency, Amazon RDS allows me to create what is called a standby instance. Now, this standby instance will be in the second availability zone. So if I were to, for some crazy reason, lose availability zone 1, my standby instance is a duplicate copy of the active RDS instance. Whenever a record is changed in the active RDS instance, it is synchronously replicated down to my standby, meaning that that operation is not marked as complete until my standby instance down here has also recorded that change. When the standby records the change, then a message is sent back to the active, and the active releases a record, and the web instance can continue going on, doing whatever it needs to do. That's how the database replication is going to work. Now, if I lose AZ1, inside of RDS, part of the managed component of it is that it will automatically recognize that the active instance or primary instance is no longer available, and the standby instance will be marked as the primary or active instance. And so these arrows that we see in AZ1 will now just redirect automatically and point to AZ2 instead. It's all part of that magic behind a managed service. So now we have a resilient architecture, right? We haven't quite got to scalability yet. We'll get there. So now that we're resilient, we've talked a little bit about balancing traffic. I do want to touch on the fact that our elastic load balancer allows for 3 different types of load balancing. Application load balancing, which is what applies to the scenario we're talking about today. The classic load balancer, which handles more classic style load balancing requirements at lower levels in the OSI stack. And then we have our network load balancer, which handles HTTP traffic and things of that nature only. For our environment, we need that application load balancer. We need to be able to have health checks. We need to be able to gear traffic based on application level content. So that's what we're using here. All right, this is our scenario so far. Next, how can we scale the application, right? We're resilient. We've got content that's in 2 different availability zones to prevent the loss of content in one availability zone. But now we need to scale. So we have 2 types of scaling that are available to us within AWS. We can scale up or we can scale out. Would anybody like to help define the difference between scaling up and scaling out? Yeah, absolutely. So scaling up is the process of increasing the EC2 instance itself, meaning choosing an instance type that has more memory, more CPU, or greater storage capacity. That's scaling up. We often call this vertical scaling. Scaling out is adding more instances. So now I keep my instance size the same, but now I have 2, or I have 4, or I have 8. That's scaling out, and it's also known as horizontal scaling. Now, different services within AWS support these 2 types of scaling differently. Some services actually require you to take the service offline in order to scale it up and then bring it back online again. Some services can scale automatically without ever being taken offline. When it comes to scaling out, some services like EC2 can scale out very, very easily, whereas other services like RDS, they just can't really scale out. They have different mechanisms to be able to provide the idea of that horizontal scaling or that scaling out. As you're becoming more and more familiar with AWS services, it will be important to remember that there is a difference in scaling and that different services are going to handle it a little bit differently. Now, we're going to swing back to scaling here in just a few minutes, so just hang tight. All right, let's flip back over to our architecture again. So this is where our architecture sits right now. We have our users that are connecting through Amazon Route 53 now to our Elastic Load Balancer. Our Elastic Load Balancer has 2 registered instances, one in AZ1 and the second in AZ2, and it's balancing the traffic between those 2. Now, both of those web instances are going to be sending any database requests up to the active database instance of RDS in availability zone 1. And whenever a change is recorded in AZ1, the active instance, it's synchronously going to replicate that down to our standby instance in AZ2. Now notice, there are no arrows pointing from our web instances to the database in AZ2 because that database is not directly accessible. The only activity that can happen on that standby instance is synchronous activity from the active or primary instance. That's it, no direct communication. All right, let's talk about how we scale into this now. So we talked about resiliency, now we're talking about scalability. So first and foremost, we can scale out our EC2 web instances. So I just add more there. And I can manually add as many as I want to and register them with the ELB, and it will automatically distribute the traffic, in this case, against all 16 nodes that I have. Now, I know some of you guys are thinking auto scaling. We're not there yet. Right now, we're doing manual scaling, and I'm paying for 16 instances for every minute that they are up and running, versus this, where I'm only paying for 2 instances. So do we want to go directly from 2 to 16? Probably not. There will probably be some steps in between. but we absolutely could if that's what we determined was required to get the necessary performance from our instances. Now, when I moved to 16 instances, has that changed anything about my database? No, it's just provided more access points into the database itself. So how do we scale the database? Well, remember, scaling is not the same. I can't just pop up new RDS instances. Instead, what I do is I create what are called read replicas. Now, these read replicas are created by Amazon RDS. We go into the console for RDS to do this, and we can distribute these read replicas across the availability zones. Now, these read replicas can only handle read traffic. They can't handle writes. So if I needed to make a change through my web application to the database, those all still have to go up to my active instance. But if I'm just asking a question, hey, can you give me the name of this image? Those can go to the read replicas, and I can create multiple read replicas in each of my instances. Amazon RDS will handle the routing of all of that traffic for me. So when I scale EC2, I can just pop in new instances, and that is called what? What kind of scaling is that? Yep, horizontal scaling. With Amazon RDS, I scale by having RDS create read replicas, and that's kind of sort of like horizontal scaling for RDS. It's not identical to it. Now, when we configure RDS in this way, it is called a multi-AZ configuration, AZ being short for availability zone, multi-AZ configuration. All right, so now I have scaled out, I can handle more traffic, but there's even more that I can do here. So I can begin to start breaking off static content on my website over to Amazon S3, right? S3 is a great object store. And for any web pages that I have within my web application, for any images or source content that I have that's static, that's never going to change, Amazon S3 becomes an excellent storage place for that content. Remember, Amazon S3 does not live inside the VPC, just like Route 53. It is not inside of a VPC. So we have to be careful and we have to remember this. It does not live in the VPC. It is also automatically scaling. It's automatically going to handle whatever traffic gets sent to S3. We don't have to worry about scaling for a service that lives outside of the VPC like Amazon S3. Now, we are going to have to refactor our web application so that it knows when traffic is out there in when content is out there in S3 versus content being inside of our databases or inside of the application itself. Now, we can take this even one step further than that, and we can introduce a cloud distribution network, or a CDN. I'm sorry, I said cloud content distribution network. For AWS, that content distribution network is called CloudFront. CloudFront is awesome because it is relevant to the region that the user is coming from. So now Amazon Route 53 points down to CloudFront. CloudFront then knows where the content is. It sends the user request to S3 or it sends it out to our VPC, depending upon what the request is. Now, notice CloudFront is not in the VPC either. It is another one of those services that live outside of the VPC and is serverless. It, again, automatically scales itself. We don't have to worry about it. We don't have to plan for it. We don't have to manage it. It's just automatically going to do what it needs to. The other beauty about CloudFront is it is aware of regions and it can gear traffic different content for different regions. This is an awesome service. If you haven't read up on it yet, make sure you read up on it because it's a very important part of a large to gigantic scale web application. All right, so now that we've got our traffic going through Amazon CloudWatch, we have a significant amount of additional control over what's going on in our interfaces. All right, so As we step forward, we're just adjusting our architecture little by little by little to make sure that we're getting the right kinds of requests that we need. Now, we've handled incoming traffic with our CDN. We've handled load balancing across our web interfaces, and we've done a little bit of scaling with read replicas inside of our databases. But there's one more thing that we can do to handle even more database traffic, and that is implementing Amazon Elasticache as a caching service. Now, what a caching service does for our web application is it allows us to store commonly accessed data from the database inside of the cache. Now, a cache is just a non-relational database. It's what we call an in-memory database. Now, the web application farm is going to hit the cache. If the content is already in the cache, it gets served up in a millisecond. If it's not in the cache, then it'll go back to the database. It'll request the content from the database stores it in the cache, and the cache serves it back out to the web farm. Now, in most web applications, 80% of the content that's used is used from a cache when we implement a cache. It's awesome because it speeds up our application dramatically, very, very quickly. So Elasticache. For those of you guys that are really interested in databasing, I highly encourage you to learn more about how caching for our databasing works, because Elasticache is an amazing service for helping us to expand out as database requests become more and more common. All right, let's reorganize our architecture a little bit here. It's the same thing it was a second ago. I've just kind of condensed things a little bit here. So I've collapsed all my web instances into one block, and I've collapsed my RDS instances a little bit differently here. But same concept. Our web instances, I could have 16 of them here, even though I only have 2 in the picture. All right. Moving on, we've got even more traffic that we need to handle. One of the issues that we deal with when we deal with these kinds of large web applications is the ability to make sure that each user maintains their session as they're working in the web application, as they're doing different things. Now, generally speaking, the session information is stored within the same database that we're working with, in this case, Amazon RDS. However, as we grow and as we try to protect our RDS instances from being overutilized, we have the ability now through Elasticache to begin decoupling the session information from our RDS database. We do that with a service like Amazon DynamoDB. DynamoDB is an excellent database option when it comes to storing session information. And so now when a user logs in and connects to our instances, they get all the way through this content and they're sitting here with the web instances. They go to Elasticache now for all of those databasing needs. And they say, oh, I'm a brand new user. I need new session information. So that session information is now stored within DynamoDB and within Elasticache. So now as session things need to be verified over the course of using the website, I'm again protecting RDS from that additional traffic. Whew, all right. Solutions getting larger, just like our audiences. So let's pause here for just a moment with the architectural size, and let's dive into scaling, because scaling is very, very important. And it's really important, especially for our servers themselves and EC2 scaling. When we look at traffic on an EC2 instance, the first thing we need to do is set a baseline. What does normal traffic look like? When we configure our EC2 instances, we have to provision capacity for these instances. Our baseline is going to help us do that. And so here is typical traffic for an Amazon.com website. And we see that during the daytime hours, we're hit pretty heavy, but overnight that traffic drops pretty significantly. And we see that about the same every single day. So using this 1 week as a baseline, we would provision our capacity to be able to be a little higher than the highest peaks that we are seeing. That provisioned capacity is then what we pay for. I pay for 100% of my provisioned capacity. It's great. until we jump out to the month view. And now that I'm looking at the entire month of November, I run into a problem, don't I? Yeah, those last couple of spikes represent Black Friday and Cyber Monday. Those days, the traffic spikes way beyond anything that exists the entire rest of the year. Now, we're not going to get into Prime Day and things like that, but those are the same situation, right? These spikes that go way beyond our normal traffic. Well, when using provisioned capacity alone, I now have to move my provisioned capacity up to handle the highest spike that I can imagine, which means that for the majority of the year, I'm only actually using maybe a quarter of the actual provisioned capacity. I'm throwing away 76% of my capacity. This is not okay. And we know this is not okay. And so we have a solution for that. And that solution is auto scaling. There we go. Finally got there. Got to auto scaling. All right, let's dive in and let's talk about auto scaling for a moment. When we look at auto scaling, there's three questions that we have to answer or ways that we configure for auto scaling. First is that we have to define what the launch configuration is. So when I have my one little EC2 instance here, I have to define when that instance is not enough and I need to scale up. What do I scale up to? What do those new instances look like? I'm saying scale up. I'm saying the wrong word. Should be scale out. When I need to pop up new EC2 instances, what do they look like? This is our launch configuration. So I'm going to select an AMI that represents the EC2 instance that I'm going to add in. Now, the beauty of auto scaling is that inside that AMI, I have my entire web application deployed. I can set up specific user data to be deployed with it. I can bootstrap content if necessary so that it is an exact replica of what already exists. And I choose, what is that going to look like? Next, I decide where. Where am I going to pop up these new instances that have been created? The auto scaling group is what I'm defining here. And inside of that, I define the launch configurations that are going to be happening. I determine the minimum number of instances and the maximum number of instances. And I determine how we're going to be doing the actual scaling itself. Where's the load balancer? All of those kinds of pieces and parts. That's part of my auto scaling group. Finally, I have to decide when. When am I going to scale? Here, I start with an auto scaling policy. These policies help me to dynamically determine if I need to scale. So it specifies when to increase and, super important, when to decrease the number of instances that are part of my auto scaling group. This is all based on Cloud Watch alarms. All right, somebody in the audience remind me, Cloud Watch versus Cloud Trail. What am I looking at when I'm doing a Cloud Watch alarm? Yeah, I'm looking at the metrics. In this case, the metrics of my EC2 instances. So I can set this to look at a certain CPU threshold and say, hey, if my CPU is above 50%, I want to scale up. If my CPU drops below 50%, I want to scale down. But it's Cloud Watch that lets me do this. Cloud Trail only looks at API calls. All right, Cloud Watch looks at the actual resource utilization. All right. The second way that I can define a win is on a schedule. So if we go back and we think about that Monday through Friday schedule, notice in the middle of the day, there was much, much higher activity than at night. I could, if I wanted to, set up a schedule that automatically at 6 a.m. scales up by adding additional instances in. So now I'm scaling to add, let's say, 2 more instances. So now I've scaled out to 3. And then at 7 p.m., I scale back down to just 1 instance to handle that overnight load. That's what a scheduled action allows me to do. Scheduled actions are great for predictable traffic. They don't help me, though, for unpredictable spikes. And that's where the scaling policies come in to help out so much. All right, so now that we've talked a little bit more about scaling, let's look at our architecture introducing our auto scaling group. And so we're going to stick that auto scaling group around all of our web instances here. Now, auto scaling is for EC2. I don't have the same kind of concept with RDS or with other managed services. In fact, most of my fully managed services like Elasticache or DynamoDB, they do all of it internally. I don't have to set up an auto scaling group. I don't have to answer any of those questions. It just automatically does it for me based on other configuration settings within that particular service. All right, so we've scaled up to the point where our large audiences, we're talking hundreds of thousands, they're being handled. Our application is performing really, really well. However, we wanted to get to 1 million, right? We wanted to get up to 1 million users. So we need to go a little bit farther. And this is where we get to our ginormous audience now. All right, here's our basic architecture now. We have our users connecting to Route 53 that sends them to our Amazon CloudFront network. CloudFront is now going to ensure that my users are authenticated. We're going to use Cognito for this. Now, this particular first request that's coming in is coming in for brand new dynamic content. I need to register a new user into a specific user group in my web application. So I authenticate to Cognito. I am an authorized admin user. My request now gets sent to the application load balancer. That then passes my request down into my auto scaling group. So I'm hitting one of who knows how many EC2 instances within that auto scaling group. Now, when we get to this gigantic size, protecting internal resources is vital. It is so important. So we are going to create a security boundary now that is going to isolate this this application load balancer and our web auto scaling group from our internal resources. Now, does anybody in the audience know what this is called? Yeah, it's called a security group. I am going to create a public security group or subnet around these resources. All right, so remember, my task here as an admin is I'm registering a brand new user in a specific user group. So the web application front-end instances are going to send me now to an internal application load balancer. This internal load balancer now can send me to other internal resources. Now, because I'm registering the new user, that's going to require me to go and hit my database. It's a new user, so Elasticache is not going to help me. So it's going to pass me all the way into RDS. Now, I go into RDS, I register that new content, but then there's going to be some kind of compute operation that's got to happen. So generally speaking, instead of my request going directly to the database, aside from maybe a check to see whether or not that user already exists, I'm going to be passed up to another set of worker instances. Now, this is the beauty of breaking down a monolithic web application into multiple components. It's because now I'm not reliant on that one scaling group, because I can set up a whole nother set of instances that are optimized specifically for the operations that the web application is going to perform. And so here I'm registering a new user. So I go up to this worker group on top, and it knows how to do specifically the job of registering new users, right? Anytime that those instances need to communicate down with the database, they just follow this line down to Elasticache and go through the concept there until they get to the database if necessary. Works the same as ever. Now, I can have as many worker groups as is necessary to meet the needs of my application, right? Have you ever gone to a website and you get to the website and they tell you that certain components or certain features of the website are going offline, right? They're not taking their entire website down, they're just taking down part of it. This is how they do that, because the front end is being handled by a separate set of worker instances than all of the other components of the application itself. It gives us a level of scalability of resilience, and of flexibility that we simply can't have in other configurations if we're working with a monolithic application, because everything must be stored on a single instance. It's really a thing of beauty when we look at this and when we scale out to this massive size. Now, don't forget our static content, because we have this whole other opportunity to use AWS's serverless services to be able to handle static and even more dynamic content through the use of AWS Lambda and other serverless services like DynamoDB. We have flexibility to be able to meet multiple criteria in very specific ways. As you grow as an architect within the AWS service life, world, you need to remember that there's always more than one way to do everything. And it's really important that you diagnose the purpose of the application that you're creating, all of the components, not just one big purpose, but what are all the small little feature purposes that you have, so that you can select the proper purpose-built services to be able to meet that need and to meet that requirements. All right, guys, that is what I have for you today. So I'm very thankful that you've hung out with me this afternoon for this session on how we architect and build out large-scale web applications. My name is Michelle Metzger. Again, thank you for hanging out with us for this restart session.